So let's start with defining what to prioritize. So when you ask people what do you want to measure, when you ask people that are product owner or people that work on the strategic level, well, they will tell you we want to gather all the data. And the answer that you should give them is no, we're not going to gather all the data. So how do you get what you really want to measure? Well, you start from the end and you say, why do you actually want the data? Well, they would say, maybe we want how many people read the article today. And from that, you go back and say, what are the events that I'm going to gather in order to get that? So the events could be clicks, they could be scrolls, they could be shares. You don't really know if a person actually read the article. This is the only thing you can measure. You can't measure what the person is actually doing. You can only get a couple of observations. And then when you gather these events, you have to be specific about what model you're using to go from these events and to conclude the number of reads. And of course, there's always an implicit model, but this has to be very explicit. And we'll come back to that in a second. But let's start with this first part. So you ask people, what do you want? And they tell you want views. And the thing about views, for example, article views or TV show views, is that they're useless. They're like the apple pie. It's everybody's second choice. If you ask anyone what they want, the simplest answer is, well, just give us views. And no one really cares about the views. If you ask any developer about their app, they know that people are using it. They don't really need to gather the data to know the views. If you ask someone who wrote an article, they will tell you that they are sure that people love the article. So they don't really need the views. And what you should actually ask them is something more like, if you could do anything with data, what is it that you would actually use for making decisions? And now they'll start blinking, and maybe they'll be happy and say, we want A/B tests and experiments, and then you get a smaller checklist of things to do. And once you have this checklist, then you can start experimenting. And here's how you actually start experimenting. Or this is, of course, this is how we did it. It doesn't mean that it's true to everyone. I want you to think of this and to think of your own use case if you do have one, and to think of how this could actually apply to you. And of course, we've been working on this for the past 2 years, so it's still just like the Berlin airport being iterated over and over again. So first, we think we want to collect the data. We want to collect it and ingest it somewhere. Maybe we make an SDK, and we want to get the data, the events that we had on the checklist, so clicks, for example, and we want to store them in some message queuing system. So what we're going to do is build an SDK that is easy to use for our products. And from this SDK, we're going to send very simple JSON files to an event API. This API is called the event API because it gets events. That's a very creative name. And then we publish those events to a PubSub. So PubSub is the message queuing system on GCP. And once we do this, we have ingested those events, and they're on PubSub. They're there. We don't have to worry about anything. But we still want to store them, ideally, in some database. So if we want to do this, then what we basically need to do is have a service that will subscribe to this message queuing system and then write to the database. And we call this service Judy, Judge Judy, because it decides whether you actually end up in the database or you get divided by 0 and then disappear. So very easy. We collect JSON files, we ingest them, and then we give them to Judy, and Judy decides what to do with them. But there's a couple of problems that happen with this. So JSON is very easy to modify. You can always play with JSON, and you'll have a lot of robots playing with your API. And people tend to have different ways of writing things. Some people love snake case, some people don't really like it. And click with a K is how Swedish people spell click. you'll end up with these developers trolling Judy, and Judy ended up not being very happy because of this. Because not only the schema is evolving all the time, but we also are sending the schema with every single event. And there's a couple of other issues that come up with this, which is that when you have different levels and you want to keep the same definition of what an event means all over these levels, it can be very hard to synchronize. So the easy thing is to actually define all of these things in one place, and that's what we decided to do. Since we know the schema beforehand and we've decided what an event is going to look like, since we have a common model for the data, how can we actually use of that? Well, what we've used is Protobuf, and you could actually use other solutions. And Protobuf was a protocol for serialization that was developed by Google. And what you could do with Protobuf is basically define, for example, a person message. And this person message includes information about the person. And then you could compile this message to Go, to JavaScript, to Fortran, whatever you're into. And then once you have this compiled, for example, JavaScript message, you can get the JavaScript from the client side and get it from the server side and use it to serialize on one part, and then deserialize on the other part. So in between, what's being exchanged is binary. On our end, what we do is we deserialize it on Judy's side, and we serialize it on the SDK side. So basically, we define the schema, and we use GitLab CI pipeline to generate and publish libraries for all of our SDKs and also for Judy. And then the SDKs and Judy fetch the schema, and the schema is versioned. So they know that so we could know that it's the same version, or if it's not the same version. And we also use this to generate the table. Now you're happy, Judy's happy, you drop the mic, but it's actually not really the case. So you still have to take care of backward and forward compatibility, because sure, you've centralized the schema, but that doesn't mean that the schema is not going to change. And when the schema changes, the SDKs, so for example, on iOS, it's going to take time for the client applications to actually catch up with you. The table should not change frequently, because the table is used by analysts, and if with every change to the event, you change the table, the analysts are going to complain, because then now they have to join over all of these tables. So what we did is we separated those two things, and we provided a mapping on Judy's side between the events and the table. Another problem that we found with Protobuf is that it is supposed to be language agnostic, but it's actually not really. So we do use a special proto compiler for Go, one for JavaScript. We have different modifications that we apply for different languages, but it works in the end. And there's a lack of support, so it does take some time to understand your problems. Now, here's the thing. You've gathered the data, you have the data on your storage, it's all good, but if you're not using your data, you're just generating a bunch of waste, and Greta Thunberg is behind your back. So here's what you want to do. You want to generate KPIs to learn, to optimize, to actually help the decision-making process inside your company. And I love the data pyramid because it kind of shows how things are built up on top of each other. And at the top here, well, this is where you achieve nirvana and you become one with the universe. You can provide AI and machine learning. Remember when I said I will not talk about machine learning? I lied, so now you know. I love the data pyramid. In fact, I've changed this saying by The Guardian that says the pyramids of Egypt could be explained as symbolic stairways to the stars, according to a British scientist. The data pyramid could be explained as a symbolic stairway to the AI, according to myself. So from now on, you actually can endorse me on LinkedIn for being a data pyramid worshiper. I'm not kidding. It actually is a skill. Thank you. So now we have the data. What do we do with it? So it's very simple. We analyze it, and then we present it somehow. So the analysis part is where you make ETL jobs, which are extract, transform, load, and then you somehow present it. It could be in form of a dashboard. It could be in the form of something that is a bit more secure and that is reliable and that has been tested over the past. And then you realize that on the analysis part, everybody ETLs. And I've taken this from a talk by Josh Wills, who at the time was a data engineer at Slack. And there's a moment when you realize that all of these users, all of these data users that you had actually do some form of ETL, especially if you give them access to the raw data. And so you realize that actually everyone, even the people on the strategic part, they're kind of looking up on BigQuery. So you want to take some control over the ETL part. And to simplify what that would actually look like in reality, you have some inputs for an ETL job. This could be the click events that we've talked about, and the output on the other end could be the articles read per day. And from that, you generate an aggregated table. This goes through some mysterious pipeline. In our case, we use Apache Airflow, and we use Apache Airflow, but we use it on a Composer environment, so we run it on GCP as well. We have this magic job that appends something to a partition today, and this job would run every so often. The problem with this is that this can happen. One day it fails, and when it does fail, you should be able to reproduce it. So the error that we did here is that we appended the magic job. And what I think is better, and this is something that, this is not necessarily true, this is something that I think is better in this case, and could be not true in other cases. And it is sometimes better that instead of appending, you overwrite the partition. And the reason why you overwrite the partition is because you want to see the data as immutable and the logic of the magic job as a versioned logic. And if you want more on this, you can check a talk called Functional Data Engineering by Maxime Beauchemin from Airbnb. Just so you know, it's biased because they built Airflow. And Airflow was built with this in mind, with seeing data engineering with a functional paradigm. So you ensure reproducibility. You want to lower the entropy of your ETL pipeline. So it's a good thing if you can practice failure in small increments and define all of your conventions in one place. And once you have that, hopefully your pipeline is more tidy than most other pipelines or than it could have been otherwise. And you'll find more tips on best practices for Airflow, especially on the same link that I shared earlier. And you'll also find principles for extract, transform, load jobs. The reason you set a set of rules is because you want to limit something. So for example, if you go on the street, you're going to find that there's a place where some cars go on one direction and other cars go on the other direction, and in between there's some lines, right? The reason there's a line there is because most of the time it's useful. One could argue that sometimes you need to break the rules. I'm not saying you should do that when you're driving, don't do that. But when you're building an ETL pipeline, feel free to do that, but please document whenever you actually do it, and it should be the exception, not the rule. So to summarize everything, and before I summarize, actually, there's a slide that we were asked to add at the end of our slide deck, which is this. You can actually go and rate the session. But the funny thing about this slide is that if you look at the title of this slide, it's very, very optimistic. It's a new era of war, sabotage, and fear. So I thought it's actually a good idea to add this slide somewhere in the presentation. So to summarize, this is what worked for us, and it might not work for you. When you're first building a data pipeline, you're almost like a baby. You're useless to the other teams, you're useless to your users, you don't really know how to do anything, but because you're cute, and because at some point you're going to be useful, and because they depend on you, they help you. So be like a baby. Thank you for being here, and feel free to ask me questions about anything that I have mentioned.